Oh, good day. Today, I'm gonna show to you the Laplace transform of cosine bt. So first, you need to find the integration of e raised to negative st times cosine bt dt. The limits are from 0 to infinity. So first, you need to find u, because you can solve this equation using integration by parts. U is equals to cosine bt. The derivative of cosine bt is equals to negative sine times the derivative of bt, which is b. So sine negative b sine bt. Your dv is equals to e raised to negative st dt. And the integration of that is negative 1 over s e raised to negative st. You can substitute it using the formula uv minus integration of v du. So your u is equals to cosine bt times negative 1 over s, so it will become times e raised to negative st. You can substitute the limits earlier so that you will not confuse. Minus the integration of v is equals to negative 1 over s e raised to negative st times negative b sine bt dt. Substituting the limits will become negative cosine b times infinity over s times e raised to negative s times infinity minus cosine b times 0 over s times e raised to negative s times 0 minus the integration of b minus b over s times the integration of e raised to negative st sine bt dt. So e raised to a negative very large number is equals to 0. So it will become 0. Plus negative times negative is equals to plus. Cosine b times 0, cosine 0 is equals to 1 over s times e raised to 0 is equals to 1. So we leave at 1 over s minus b over s, the integration of e raised to negative st sine bt dt. Limits are from 0 to infinity again. Then you can solve this equation again using integration by parts. So find u again. U is equals to sine bt. The derivative of that is equals to p cosine bt. And your dv, don't forget the dv. dv is equals to e raised to negative st, and integration of that is negative 1 over s e raised to negative st. applying the formula again, uv minus integration of v du, we will come up with, copy the 1 over s minus b over s, don't forget this, times u is equals to sine bt, v is equals to negative 1 over s times e raised to negative s t. Limits are from 0 to infinity, minus the integration of v is equals to negative 1 over s e raised to negative st times du is equals to b cosine bt dt. So multiply b over s, negative b over s to the whole equation later. So copy 1 over s minus b over s, substituting the limit, come negative sine b infinity over s times e raised to negative s infinity minus, will become plus sine b times 0 over s times e raised to negative s times 0. So minus become plus b over s integration of e raised to negative st cosine bt dt. So e raised to a very large number, it will become 0, and sine 0 is equals to 0, it will become 0 over s. So 0 over s is 0 times 1, 0 again, plus 0. So negative bs times positive bs is equals to, copy the 1 over s, negative b over squared. Okay, so as you can see, e raised to negative st cosine bt dt is the same as this. It's equal to Laplace of cosine bt. So let Laplace of cosine bt is equals to y. So substitute it by y, become y. And don't forget there's a y here, because cosine bt. So transposing this to the left, it will become positive. So y plus b squared over s squared, y is equals to 1 over s. So there's a 1 here, so you can add b squared over s plus 1. It will become s squared plus b squared over s squared times y is equals to 1 over s. You can cross multiplicate, so the answer will become s over s squared plus b squared, y is equals to, and substitute the Laplace of cosine pt equals to s over s squared plus b squared. And that's the final answer. And that's how it is done.